Alright, so we are back now here. So we've seen that our phone to our device also, our mobile device also has an IP address. Okay, so we are comfortable with that. Let's get back here. Alright, so now the next thing is that how are these devices going to communicate? What's the framework or what's the structure? Is there any guidelines? Because you saw that my phone is on from a different manufacturer. The laptop is also from a different manufacturer. So how do you ensure that they all speak the same language so that everybody interprets the language equally? Because we said that we want to transport data, and this data, if a little bit computer savvy, you know that it's ones and zeros. So how do we make sure that the ones and zeros that are going to be interpreted from one end user or one client is the same, that will be understood by another end user or another device? And that's the work of the OSI model, which has been concise to the TCP/IP model. So the OSI model is just a framework that helps us know how devices are supposed to communicate. So we have the physical layer, and that's mostly just the physical layer, as its name, just establishing the connectivity. The data link layer goes on with how do we move the data. The network layer goes with which host needs which information. The transport layer is more of confirmation that the data has reached that particular host for that particular host or user. Accept it as so. And then the top one is just application layer, which is we actually seeing the data that we've shared. So that's the work of the OSI model, and every layer has a protocol and a device that works there. So the physical layer, we understand that is a model, but what's the implementation of the physical layer? We have to have cables, we have to have Wi-Fi. The data link layer too, what's the implementation of that? We have to have a network interface card, we have to have switches. What's the implementation or the physical visibility of the network layer? We have to have a router to do that work for us, so that we can actually ensure that we are actually being able to move the data from one network to another network. So that's the essence of the router. And we have the transport. The transport is, okay, I get it, I'm going to this IP, I'm going to this host, but when I go to this host, is there someone in particular I have to give the information to? Yes. So we have a port in this domain, and also we have TCP, UDP. I won't go into too much of that, but it's more of how the information is being shared. What's important is that you need to know that there are devices and there are protocols on each layer, and the final layer is the data layer. We are actually seeing the data. So each layer has its own way of how the data is going to be morphosized or called. When it's in the data link layer, or when it's mostly at the beginning, it's mostly bits. When it starts moving up, it becomes a frame. When it goes to the network layer, it becomes packets. So when you have a packet, then you know that you have IP addresses, because packets have the source IP address and then the destination that you are trying to send your IP address to. And then the transport layer is more of, fine, I get it, but who in particular am I going to give this information to? So more of ports. And then the data layer is the actual visibility of the layer. For now, just accept all this. You appreciate it later on, but moving forward, know that packets is very important. Once you have packets, meaning that there's a source and there's a destination. So that's packets for you. Alright, so we are okay with the OSI model. Now let's go back now. Realize that when we made the connectivity, when we check the IP addresses, we saw some parameters. Those parameters we saw along our IP addresses also helps us a lot as developers. So some of the parameters we saw are IP addresses, which we know that, hey, that's me on the internet. That's me on the internet. Don't worry. We have the subnet max. The subnet max also allows you to know which class of IP and also the number of hosts and the number of networks down on the network. And the other one is default gateway. And you realize that because we are connected to a router which is on the network layer or the L3 layer, because we're on the L3 layer and there's a possibility of we speaking to other networks, there has to be an IP address for that router. We have our own IP address as a host, but because we have a router that is going to talk to the outside world, there's also an IP address for it. Don't worry, you won't be lost. And we also have the DNS and the DHCP server. DHCP server is what's going to assign the IP addresses to all the devices. So realize that my mobile device had an IP address different from what I have over here. That's because there's a DHCP server doing that. And then we also have a DNS server. The DNS server also helps us to, if we want to locate other devices on the internet, what's their IP address in case they give us a name. So I may want to go to Stacy's house to visit her or to give her a gift. I go to Stacy's house, and then I know Stacy's address is maybe in my country our digital addressing system will be GA, then the address. I know this Stacy's address, but I don't want to go with all these numbers. All I want to say, I type Stacy address, and I type Stacy address. It just results for me to get what their physical address or their IP address. So that's just a way of redoing some mapping or a lookup, so we don't have to stress ourselves on aliasing. So we don't have to stress ourselves to get to put all the physical address, the digits all in our head. No, we just map it and then it alias to Stacy. Alright, so once we connect with our router, the key takeaways are IP address, the subnet max, the default gateway, and also the DNS server. Yeah, and also you can also look at the DHCP, but most of the time the DNS server. So these four play a critical role. We've understood this. Now let's continue. So have this at the back of your mind. Have this at the back of your mind. Alright. Now the IP addresses, sometimes they are public, sometimes they are private. What does this mean? What this simply means is that there are some resources or there are some devices. Let's say James' laptop is not meant, the resources or the information he has on his laptop is not meant to be shared with everybody on the internet or all users in the world. So in order to do that, James has a private address for that, or he has been, in other words, he has been cut out of society by giving him a number or an identity which excludes him from the society, and that is being done with an IP address. So we give him a private IP address. With that private address, no one can have access to his information because it's very confidential to him, or he doesn't want everybody to have that access to that information. So because of that, he's on a private IP address. When you're on a public IP address, for example, is your school has some data that wants your parents to be aware of. They can't keep that on their network or whatever community they set up in their school. All the devices, they can't keep all the devices in that community. So no, for this information, let's have every parent or anybody in the world have access to this information. So we go on the internet and we get a public IP address, and that public IP address makes it possible for people to resolve or to route to the school's resource data to have access to any information that they want because they're on a public IP address. So that's the key about public and private IP address. And sometimes the IP addresses are static or dynamic. We don't really care about that. But what's important is the public and private. Fine, static to keep in your mind. Dynamic to dynamic means that the IP addresses that are assigned to the host, they always change. So if you go to Stacy's house and it was initially this IP address, it was initially GA, and she's still living at maybe a place like in Ghana, like East Legon, and the next day you hear that Stacy's IP address has now changed to this 27, which means that now Stacy's location, her house, the address to her house is always changing. So it could be that Stacy is always moving from one location to another location. And status means that it is fixed. If you are visiting Stacy all the time, this is her address. It doesn't change. Alright, that's fine. Okay, so now we are done with public. So these are the ranges of IP addresses. So we look at the classes later. So if it's private IP address, anytime it's 10 and goes, it's private. It's 172, so 192.168 always in the private, 172.168 always in the public. always in the private as well. So 172.168 is always in the private range. 192.168 is always in the private range. Any other thing is in the public range. So that's for you to just accept. And we know the reason why we've explained public or private. Okay, so now let's look at subnet marks and CIDR notation. We said that IP addresses are all going to be assigned, and most of the time it's done by a DHCP server. The DHCP server is going to assign IP addresses to everybody on the host, every host on the network. So for all hosts on the network, there's a DHCP server that is going to assign us our IP addresses so that we can all have IP addresses to share information. Okay, so if we take the context of a sales department, marketing department, or design department, realize that sales department will have their own IP address, which will be assigned by the DHCP server, and that of the marketing department also have their own set of IP addresses that will be assigned by the DHCP server. Fine. Well, what we are going to say is that because of that, some IP addresses, it becomes there's a problem when we have a lot of IP addresses, but not all IP addresses are being used. So it becomes a way of, in other words, we have not efficiently using the number of IP addresses. So every IP address has a network and a host bit. So there's a network bit and a host bit. The network bit is just for you to know the network which you are inside. In other words, fine, I get it. I know we're in the same class. So we're in a class of 50 boys, or 50 boys and girls, or 50 students. In the 50 students, we can create groups out of the 50 students. So we want to have groups of 10. So 10 groups. So if you have 10 groups, how many people will be in one group? So 5 people in one group. So that's 5 people in one group. You can have that. You can also have that. So that's a possibility. Or you can have 10 groups. Yeah, 10 groups. Then 5 people in one group. So that's perfect. Yeah. So in each of the cases that we take, where we have 10 groups, we have 5 people in each group. Then there has to be 2 people in each group, because that's the way we'll get the total number of groups. So if we have 10 groups and we have 5, it's a lot of, so I said 50. So if it's a class of 50, then fine, then that's okay. That's okay. Alright. Yeah, so if that's the case, then we have our scheme. So in one class we decide to go with 10 groups, 5 people in each group, and with that we are okay, because we are able to create a network out of that. So that network we've created is our own scheme for creating the number of groups we want. If you are not comfortable with that and you want to go with another way, you could say that fine, I'll do 25, 2 groups, but 25 students in each group. That's also another way of going around it. So what I'm just trying to say, that the same with IP addresses. The IP addresses, the resources or the hosts or the devices, they are out there. But how do we distinguish between each host and each network? So we have a network, we have a host, we have groups, we have students. So groups and people, but it's all in one word, class. That's the same way with the classes. So class A, class B, class C, as simple as that. So if you go with the, I'll talk about this later. You go with the number of hosts of 16 million. How many networks can we have? 127. So you have 127 networks. So you have 127 groups. But in each group we have 16 million, and which could be a lot, because probably we are just setting up a small classroom, and we having all this number of hosts is excess, or is redundant, or is we don't need it. So we want to efficiently use the IP addresses. So to do that, we have something called subnetting. So subnetting is going to help us to efficiently use the IP addresses, so that we do not we do not mess or we do not misuse our IP addresses. So that's it about subnetting. So I will slide to a small session here. That's a practical session here for us to appreciate the subnetting. Alright, so let's go and get that understanding from an actual calculation. Alright guys, so let's look at the practical subnetting. Yeah. So we've understood that we have an objective, we have a home setup here. It could be any business objective or use case. And that business objective or use case, we want to create some number of networks based on the business requirement or what our use cases. And the classful IP addresses have fixed number of subnets and fixed number of networks and hosts that you can have. So A, B, C. It tells, for example, class C tells you that you can have 2 million networks, which is a lot of networks. But you can only have 254 hosts for each networks. And the default subnet max is 255.255.255.0. And you know the IP range is 192. It starts from 192. So given an IP address of 192.168.0.1, we want to create our own subnet out of this, because to assign 2 million networks to a small use case or a small objective is not the best. We are not looking at a hotel setup. We are looking at something like our office or something like a department. And a department, it could be a large corporation, medium-sized business, it could be a small-scale business, and the cases are low. Alright, so there are two ways of doing this. One way is that we'll be given a subnet max. We create our own subnet max. When we create our own subnet max, we actually go ahead and create the number of networks and hosts that we have. Or we can hypothesize the number of subnets that we want, or the number of hosts that we want, and go ahead and do our work. So let's look at the case whereby we create our own subnet max. To do that, we're going to represent every decimal here in this binary form. That's for the subnet. So we take 255 in this binary form, be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So each digit here is an octet. So for each octet is 8 bits. And all the ones that are active is the network. And any other thing here is the host. So we're going to steal 2 bits from here. Stealing 2 bits from here is going to make the network length increase, and the number of bits here is going to reduce. So if it's 8 and we take 2 out of it, 6 bits is going to be left for the host, and then the 2 is going to be added to the network, or for our network. So the new network length, the original network length for this was 8 plus 8 plus 8, which is 16 plus 8. So 16 plus 8 is 24. Then we added 2 more, plus 2. So this is 6. This is 26. So our new network length is 26. Alright, so with the length of 26, how many subnets can we have and how many hosts can we have? So our new network length is 26. So before we even get that, let's actually find what the new subnet is, because we have created a new subnet. So to find the new subnet max, we'll just pick only the last octet of this and find its decimal representation. So 1, 2, that's 2, then 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. So we're going to convert this to this decimal, and to do that is 2 to the power 0, 1, 2, 3, 4, 5, 6, 7. So 2 to the power, any number to the power 0 is 1. Then 2 to the power 1 is what? 2. 2 to the power 2 is 4. So now it goes multiples, they are multiplying by 2. So this is 2. 4 times 2 is going to be 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. And that's because if you take, for instance, 2 to the power 7 is the same as saying 2 to the power 5 times 2 to the power 6 times 2 to the power 1. So the former and the new one. So the 2 to the power 6 2 is what? 2 to the power 5 times 2 to the power 1. And 2 to the power 5 is the same as saying 2 to the power 4 times 2 to the power 1. So it boils down like that. That's why it's a multiples of 2. So we're going to do 128 plus 64. So 128 plus 64. Sorry. 128 plus 64. So 8 plus 4 is 12. Then you have 1 plus 2, which is 3. 3 plus 6 is 9. And you have 1 down here, so 192. So our new subnet max is going to be 255.255.255.192, and the length is of 26. So this is our new subnet. So these are new subnet masks that we are going to use to create our own office setup here. So with this understanding, let's go down a little bit deeper. So what we're just right now going to do is that we want to find how many networks and how many hosts. So let's go to a new page and see we have 255.255.255.192 of 26. Yeah. So how many bits, how many subnets can we have? The total number of subnets is the number of ones we turned on in our host bit. So how many ones did we turn on in our host bit? If you do remember clearly, we turned only 2 bits on. And then that will give us the total number of subnets. So you can have 4 subnets here. But how many hosts can we have in the subnet? And that will be the remaining bits we left on. That was 6. If we have just it represented like this, you can actually just do 32 from 26. You go to here, you have 6 here, you have 6. So that's the number of host bits left, because we said that the total length of this, which is the network length, is now 26. So you can actually find the remaining bits by just doing 32 from 26, and that's going to be 6. Alright, so for subnet 2 to the power 6, 2 to the power 6 is actually 2 to the power 5 times 2 to the power 1. 2 to the power 5, if we do remember clearly, is I think 32. So it's actually 2 to the power 4. 2 to the power 4 is 16 times 2. That's 36. Sorry, 32. Sorry. So 32. Right. So we are good here. So we're actually going to have 32 times 2. This is 64. So we have 64 devices. Right. So that's coming from here. 64. Right, so literally what this simply means is that if you take 2 bits out, 2 to the power 2 is going to be 4 subnets, and you have 64 devices that you can have within your. So you can only have 4 subnets, and you can only have 64 devices. That's what it literally means. So this subnet mask has been given to you. If that's convenient for you, you can go ahead with your setup. So that's just one thing. So later on, if it happens that you don't want to go with this approach, so these are approximate. Actually 64 minus 2, because you take 2 IPs out, one for broadcast and one for the network address. So it's always minus 2, but this is just hypothetically for you to know that that's an estimate. Alright, so this is the one approach where we've created our subnet max. Okay. Now the next hypothesis be like, I rather want to tell you the number of subnets I want, and tell me the subnet max that I'll use, or the number of hosts I want, and you tell me the number of subnets. So more time you want to look at the number of subnets, because it's much more convenient based on your use case. If it's a hotel, you may decide to put all of them on one subnet. Or if it's a hotel, you may decide to create a particular subnet for the business functions, in a particular subnet for customers. That one too is also there. So it's how you go about your IP addressing, or how you do your calculation. So let's say that I want 10 subnets. That's what I want. I don't care the number of um, hosts are in the subnet. If I also want to care about the host, I can give a host, but the host most of the time may not be known because you don't know how many devices somebody will bring to your unit or to your hotel. It depends on your use case. So yeah. So if that's you want 10 subnets with the same IP address 192.168.0.1, how do you get your subnet max? So 10 subnets is simply saying that 2 to the power x has to be equal to what? 10. That's what I'm just trying to say. So we want to find the number of bits here. That will give us what? 10. And if you do the mathematics very well, you realize that 2 to the power 3 is 8. So yeah, if you go to 2 to the power 4, it's actually what? 16. So in other words, you have to get more subnets to do this work. 8 is less, so 16 is a little bit higher. So we can say that, okay, fine. Because of this, we want to have more. So we can actually do our 10. So the remaining 6 will be redundant, which we may be okay with. So to do that, we go ahead and say that then the subnet max for this configuration is that we took 4 bits out of the network, out of the host. So 4 bits, looking at only knowing the default XXX, we took only 4 bits here. 1, 2, 3, 4. Then 1, 2, 3, 4. So 4 bits is left for the host, 4 bits is left for the network because we are going with 2 to the power 4. So what is going to be the new subnet for this? So we start with 2 to the power 0, 2 to the power 1, 2 to the power 3, 2 to the power 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 2, 0, 1, 4, 5, 6. 2 to the power 0, 1. So no 2 to the power 2. Sorry, but what we care about is 1, 2, 3, 4. So it's 2 to the power 7 plus 2 to the power 6 plus 2 to the power 5 plus 2 to the power 4. Because that's the only one that one. And we know that 2 to the power 7 is 128 plus 64 plus 32 plus 16. So let's calculate this. So 32 plus 16, this is going to be 4, this is going to be 8. 48 plus 64, this is going to be 12, this is 10. 112 plus 128, this is 10. This is 3 plus 1, 4, so 240. So our new subnet mask is going to be 255.255.255.240. This is what's going to help us to create the 10 subnet that we are looking for. And the number of hosts from what we've done is going to be 2 to the power 4 minus 2. So it's literally going to be like the same. So 16 subnets. And we've literally 16 hosts. So this is the subnet, and then this is the calculation for the number of subnets and hosts. And then the new subnet, the new network ID has increased. So the increment was 24, which we know is default. 8 plus 8 plus 8 is 16. 8 plus 8 is 16 plus another 8 is 24 plus 1, 2, 3, 4 plus 4, so 28. So our network length is now 28. So this is the CIDR notation that we've just looked at. If you still doubt, if you do 32 from 28, the number of bits left is for the host. So you just do 2 here, 2 years. What plus what will give you 12? And that's going to be 8 plus 1, 2, 3, 4. We took 4 out. Yeah, so 8 plus 8 plus 4, sorry, will give you 12. Yeah. So that's it for you. So we are okay, and then this is just for subnet calculation. So we're going to go online and check our calculations and we'll close it from here. Alright guys, so let's go ahead and check our calculations online. So we'll go and use a subnet calculator online. So let me just get my browser here and let's go to IP subnet calculator. Alright, so what we just want to confirm our results that we had. That's all that we want to do. Yeah. Okay, so first of all, we did two calculations. We had one, we created a subnet max, the other one we gave a subnet max based on the number of subnets that we wanted, and that was the use case for that. So our first use case, I have the images here. Let me get the images. I think I saved them my pictures. Yeah, so SBU1 and SBU2, let's open them. SBU1, and then we also have SBU2 too as well. Alright, so SBU1, we used an IP of 192.168.0.1, so let's go and enter that here. 192.168.0.1, and we do know that this is a class CIP address. We've seen this already, class CIP address. So this is class C, and let's confirm the subnet that we created. So we created a subnet of 255.255.255.192. so it's the network length is 26. So let's see if we have 26 here. Oh, that's good, so it's correct. So 192 actually gave us 26, so which confirms that this subnet max was right. So we are good to go. So let's also look at the number of bits, that's the number of hosts that were created for it based on our calculations. So roughly you said 2 to the power 2, and we said 4 subnets, 64 devices roughly. So let's go ahead and compute this and see. So how many? Now total number of hosts is 64, so it's good, and the usable is 62, so we are good to go. And then we have all 4 possible 26 networks, so which is good news. So our calculation was correct because it said it's 64, 62, and we have so 64 devices and 4 subnets. So that's correct. That's actually correct. So we are no further away from the truth. we actually got it correct. So that's fine. And then it gives you the number of total number of networks. So it says for all 4 possible 26 networks for the 192.168.0 IP. So it starts at 0, then it's 64, so the next 64 bits, 64, 64. So this is the first usable IP address, the next set of usable IP address, and then it goes on and on. So the reason is -2 is that you take two IP addresses will be taken, one for the broadcast and one for the network address. So that's the network address. So we're all on the same network because it's 0, around 0, and we terminate at 62, but we start at 1. So we're all at 0, 64. So we start at 65 and we terminate at 126. So it just helps you to know the network address, so you know which network you're on. So if I'm on this network of 0.0, there's no way I can I'm on a different subnet. So just this for you. That's just, by the way, the network address is just for you to know which network all the IPs are working with. So if you take the case of the sales department and the design department, this is one network address, this is another subnet, this is another subnet. So that's the essence of the network address. So all the devices here is to start from the range that it has said, 0 all the way to 63. Then the next one is 64. So it starts from 65 all the way to the next 64 bits. which is going to be 128 thereabouts. Yeah, so minus 2. So that's just by the way. So our calculation was right. So that was the first case, and then the other case we looked at was we decided, let's confirm if what we actually calculated for works, whereby we said that we wanted 16, roughly we wanted 16 subnets and 16 hosts. So we had a max of 255, 255, 255, 240. So let's confirm that we have 255, 255, 240. Alright, so we have it here, and let's see if it was also 28. The network length was 28, correct, so as well 28. So this should give us the total number of networks and subnets. So total number of subnets or networks and the total number of hosts for that subnet. So we are good. So let's calculate this, and we are supposed to see roughly 16 for each, 16 bits, 16 hosts. So which is also correct. So 16, total number of hosts is 16, and then all possible 16 IP addresses. So this is one subnet, this is another subnet. So we're all on different networks, we are not on the same networks. As long as from 01 to 014 you are on one network address, but when you move into the 16, 17 to 30 you're on a different subnet. So that's just by the way. So this is very correct, and we are okay with our results. So if you are still confused, just know that we've created different networks, and every network has an address. So 00 is one address, this is another address, this is another address. So they are all different addresses, they are not on the same address. They are not on the same address. If they're on the same address, you would have seen it. So how do you see it? So let's go back and let's pick the default. Let's pick the default. The default is 255, 255, yeah, and calculate this. So good. So we realize that class A, class B. Sorry, I didn't select the class. Let me select the class. Oh, I did. So that's class C. So calculate. Right. So let's check. So class A, class C. Sorry. So we have 255 hosts. Here it doesn't give us a breakdown. Wow. That's a little bit short. I thought we were going to see all the 254. Okay, because the number of hosts is a lot, like 2 million. The number of networks is a lot, 2 million. So it's not giving that to us. Okay, no problem. That's fine. It's quite huge. Yeah, so don't worry. But the understanding is there that it's on a different subnet. So if you are still struggling to get it, just take it from me that we've actually done the calculations and you are seeing it. So I'll see how I can get a practical session for this with regards to actual configuration, because once you have this subnet and you go to your Windows machine to configure it, you have to statically actually type all these subnet IP addresses. So what do I mean? You have to go here and then you come to your network properties, then you say this is the subnet you want to use. So you specify the IP address 168.0.1, and then you give it the subnet max. The subnet max we want to use. Let's pick the which of them should we use? We had two cases, so let's go with the 4, the one that we had 4 each. So I think it's the 4 subnets. So let's go with that one. So let's go with the the length of 26. Let's go with the length of 26. So the length of 26. Let's calculate it again. Alright, so sorry, let's check, let's copy this again. Class C 26. Okay, so it's all is here. sorry, I didn't see it. So it's 26. So let's. So this is it. All right. So that'll be it for understanding the subnet and then the CIDR notation that we just looked at. So I think that will gradually make this picture clearer as to what we're actually doing when we say we are subnetting and creating different networks for our business objectives. Alright, so we are still not yet done. We are going to enter into another lab session, and this time we are entering the lab session as to know some network command tools that we find handy, or we find handy as a developer. Alright, so that's the next session, so let's just dive into it.